Our first terms, 2 times 2, give us 4. Our inner and outer terms go away, which was the whole purpose of doing this. And last times last is positive 13 times negative 13, which is negative 169, times I squared, which changes the sign. Please do not try to reduce 16 and 4. Remember, this is a group, as is this. But you can combine 4 plus 169 in the denominator to get 16 minus 104I divided by 173. The only way you can reduce this fraction is if 16, 104, and 173 were all reducible by the same number. And there is no number that does it. So the answer was 16 minus 104I over 173. Number 13, we're faced with the same problem. We have an I in the denominator. As this fraction stands, we can add nothing, we can subtract nothing, we can divide nothing. But we can remove the I from the denominator by multiplying by the conjugate, both at the top and the bottom. Now in the numerator, we have to go through the entire process of FOIL. 7 times 8 is 56. Outer times outer is 7 times 13, which is 91I. Inner times inner is negative 29 times 8, which gives us negative 232I. And last times last is negative, big number, 29 times 13. $377, but then the I squared changes the sign. In the denominator, 8 times 8 is 64. Your inner and outer terms cancel. Last times last is negative 169, but the I squared changes the sign. And then cleaning up this fraction, we're going to add our like terms. 56 plus 377 is 433. Positive 91 minus 232I is negative 141I. And in the denominator, adding my like terms, I have 233. The answer was 433 minus 141I divided by 233. The instructions for number 15 is to find the y-intercept and the equation of the axis of symmetry. In the beginning, we said that the y-intercept of a quadratic function, x is always 0, and the constant term, which would be positive 2. So your y-intercept is at positive 2. The axis of symmetry is found by the equation x equals negative b, over positive 2a. b is 5. So that's negative 5 over 2 times a, which is negative 2, which gives us negative 5 over negative 4, or 5/4. So the y-intercept was positive 2, and the axis of symmetry is x equals 5/4. For number 17, you are asked to identify the graph of this function. The first thing we notice is that it opens down, which automatically eliminates choice A and B. Then we notice that it crosses the y-axis at negative 2. Both choices C and D cross the y-axis at -2. So the way I'm going to figure out which one it is I'm going to find the axis of symmetry using x equals -b over 2a. b is -1, so -b is 1. 2 times a, which is a -2, gives me an axis of symmetry of x equals -1/4. That means that the center of my parabola is on the left side of the y-axis. Making D the correct choice for number 17. Number 19 asks us to identify if this function has a minimum or a maximum value, and then what is that minimum or maximum value. By simply identifying if the parabola opens up or down, we can tell if it has a minimum or maximum. Because the x squared term is positive, it opens up, which means it has a low point, so it has a minimum value. You have just eliminated choices B and D. Now to find that minimum value, we need to know the y coordinate of the vertex. You cannot find the y coordinate without the x coordinate. So first, we are going to find the x coordinate with this formula. B is -6, so -b is 6. A is 2, so 2 times 2 is 4. My x coordinate is 3/2. To find the y coordinate, I must take x and substitute it in and solve. Remember that your order of operations requires you to square before multiplying. Therefore, this is 2 times 9/4. Here, 6 times 3/2 is 18 over 2, or 9, plus 6. 2 times 9/4 is 18/4, which gives us 4.5. -9 plus 6 is -3, and 4.5 minus 3 is 1 1/2. So this one had a minimum value of 1.5. Number 21, we are asked to solve the equation by factoring. We already have our equation set equal to 0. We know that x and x give us x squared. We need factors of 48 that subtract to give us 8. When we subtract, we want to get positive 8. Next, we must set each factor equal to 0 and solve for x. Therefore, my answers for x are -12 and positive 4. In a little while, baby, I'm almost done. Number 23 has a decimal in it. And if you recall, we can get rid of things in equations as long as we multiply every term by the same. If we have fractions that we don't want, we can multiply every term by a common denominator. Create an equivalent equation, but we no longer have fractions. If we don't want decimals, we can figure out how many places we need to move that decimal point and then multiply all terms by the appropriate multiple of 10. In this case, if you multiply 4.5 times 10, it gets rid of the decimal. So we will multiply all terms by 10, which will give us 40x squared plus 110x plus 45, and 0 times 10 is still 0. Looking at the trinomial, all of these terms are divisible by 5. Factoring it out, it leaves me with 8x squared plus 22x plus 9 equals 0. To factor this trinomial, I need factors